Hi friends, now I am starting introduction part of chapter 2 Polynomials, subject maths, standard 10. I am starting with very basic things. It may happen that you already know it because you learn in the standard 9, but I just want to give complete information regarding this chapter, and also whatever you learn I just want to recall it. Okay, so first of all I start with very basic things, and it is 3x square. Now in that total three things is there. One is first of all this 3, it is called as coefficient. Second x, it is called as variable, and 2 is our exponent. You can also say power. Okay, exponent and power both are same. So whatever numerical value joined with the variable, it is called coefficient. Variable means whose value we can change, and exponent power, it shows that number of times variable multiply. Okay, and combine, if we combine these three things together, then it is called one term, right? 3x square is one term. Now if we have more than one terms, that I am writing here, more than one terms are joined together and makes algebraic expression. If we join, otherwise combine more than one term, it becomes expression. I am writing one example here. It is 3x square plus 5x minus 2. It is one type of expression, right? Now what is the difference between expression and polynomial? I will explain you later. First of all, we need to define how many terms are there. So one thing I write here, terms are separated by addition or subtraction process. Okay, multiplication and division process does not separate the terms. For separation of terms, we need addition or subtraction process. I'm writing some example here. 3x square, it means 3 multiply x. But if we join together, it becomes 3x square. Means it is a single term. So we cannot say that, okay, here is, we cannot say that here is three terms are available. Okay, here we cannot say that three terms, but it is a single term. Multiply process does not separate the terms. Okay, one more example I'm writing here, that is 5 multiply x divided by 3 minus 2 multiply x plus 3. So how many total terms are there? Again, multiply and division does not separate the term. That means it is a single term, 5x by 3. Then minus sign is there. That means second term start. It is a 2 multiply x. Multiply does not separate the terms. That means 2x. And at last plus 3. So total 1, 2 and 3 terms are here. Okay, so number of terms is equals to 3. Only addition and subtraction separate the terms. Okay, let's move forward. Wait a minute. Okay, then difference between the polynomial and expression, right? So for polynomial, there is one condition, actually two condition we learn in the standard 9, that is exponent of variable must be whole number. I am combine this two condition because in standard 9 we have learned that exponent of variable must be positive number, otherwise 0, or exponent of variable is always integer number. That means two condition when learn in standard 9, non-negative, simply I am writing, okay, sorry. So two condition we learn in the standard 9. First condition is exponent is non-negative, and second thing is integer number. So ultimately I am writing here exponent of variable must be whole number. Okay, then I'm writing some example here of algebraic expression and polynomial. So first, 2x cube plus 5x minus 2. It is an algebraic expression, but it is also called as a polynomial because exponent of variable is whole number. In second condition, here I am writing 2 under root x. Now under root x means x raised to 1 upon 2. Now 1 upon 2 does not belongs to whole number. W is a set of whole number. Because the answer of 1 by 2 is 0.5, it is not an integer number. That's why 2 under root x minus 5, it is algebraic expression but not a polynomial. Third example, that is 3x raised to minus 2 plus 6. Now you can see here exponent is equals to minus 2, and whatever condition we apply, that is it must be whole number. So minus 2 is not considered in whole number. That's why 3x raised to minus 2, it is an algebraic expression but not a polynomial. Okay. Next is polynomial is defined for one fixed variable. Polynomial is defined for one fixed variable and it is represented by p of x. Now how we can read p of x? Polynomial of variable x. P of x means polynomial of variable x. So I am writing one polynomial here, 5x square minus 3x plus 9. You can see that here x is our variable. So I am writing here in bracket x means polynomial of variable x. That means polynomial is defined for variable x. Now some examples I am writing here. Example, p of x, that means polynomial of variable x is equals to 5x plus 3xy, and find p1. Okay. Now if you look at carefully, then here two variables are present, x and y. But we define polynomial for the variable x only. So for this polynomial or for this example, y is constant. For this example, we can consider y as a constant. Okay. Now find p1. That means in place of x we need to put value 1. So I am putting here x is equals to 1. Then p of 1 is equals to, now in place of x put 1. So 5 into 1 and 3xy in place of 3, x in place of y, and y as it is. So final answer, 5 ones are 5, 3 ones are plus 3y. So 5 plus 3y, y as it is. Okay. So polynomial is defined for one fixed variable. Second thing, it does not mean that polynomial is always written as p of x. It may be p of a even. That means a is your variable. So here variable can be any alphabet, a, b, c, d, x, y, z, any. It does not necessary that we always writing p of x. Okay. It can be p of a, p of y, even. Okay. Next, some specific name of polynomial that we already learned in standard, I think 8. Specific name of polynomial. If in the polynomial only single term is there, then it is called monomial. Example, 3x. 3x is a single term, so it is called monomial. Second thing, if two terms are present, then it is called binomial. Okay, two terms present. So example, 3x plus 5. Addition or subtraction process separate the terms. Here total two terms is there, so it is called binomial. Third thing, if 3 terms is there, then it is called trinomial. 6x square, one term, plus 3x, second term, plus 1, third term. So 3 terms are present. That's why it is called trinomial. Next, if more than 3 terms are present, more than 3 terms, 4, 5, 6, any terms, it is simply called as polynomial. Okay, then there is no specific name. And even all these 3 types, it is also called as polynomial, but it's just a specific name. That means 3x is also polynomial, 3x plus 5 is also polynomial, but simply some specific name is there as per the number of terms. Okay, next topic, degree of polynomial. Now degree of polynomial means, I'm writing here, highest power of variable. Highest power of variable. Power means exponent, but look at this word carefully, variable. Highest power of variable. It does not mean that highest power of coefficient. We does not consider the exponent of coefficient. We just only look at what is the exponent of variable. I'm writing some example here. First is 3x square plus 5. So highest power of variable is 2. That's why degree is 2. Okay. In second equation, example is 6 raised to 5 and x. Now exponent of x is not given. That means exponent 1. So we do not consider this 5 because it is the exponent of coefficient. So for finding out degree of polynomial, we do not consider exponent of coefficient. We just only look for the exponent of variable, and that is 1. So my answer is 1. Okay, third thing. If polynomial is not defined for specific variable, then it is of the form 5x square y square plus 6x cube. So simply, what is the degree of this expression, otherwise polynomial? So you can see that maximum exponent is 3, but I am writing here 4 because in first term it is written that 5x square y square. Here variable is not fixed, then x and y both are the variable for us. So total exponent total exponent of x and y, 2 plus 2 is equals to 4. That's why I'm writing here degree 4. Highest power of variable, but it is for the one term only. Okay, so here 5x square y square. So total exponent of variable 4, and in second term 3. So highest number is 4. That's why I am writing here degree 4. Okay. Next is the types of polynomial as per the degree of polynomial. If degree of polynomial is 0, then it is called zero polynomial. It is also called as constant polynomial. I'm writing one example here. Example 6. It does not have a variable. Okay. It does not have a variable. We can also write 6 into x raised to 0 because exponent 0, that means answer is 1. Okay, so I can write 6 ones are, it is also equals to 6, and in place of 1 I am writing here x raised to 0. Now highest power of variable, it is 0, so degree of polynomial is equals to 0. It is called zero polynomial or constant polynomial. Why constant polynomial? Because variable is not there, then 6 is constant for us. That's why it is called constant polynomial. Second thing, if degree of polynomial is equals to 1, if degree of polynomial is equals to 1, then it is called linear polynomial. I am writing one example here. It is 5x plus 3. So highest power of variable, that is 1. So degree 1, it is called linear polynomial. There is one reason for the name linear polynomial, because it always give, if we draw the graph of this polynomial, it always gives us straight line. That's why it is called linear polynomial, because its graph always show one straight line that we will discuss later. Next, if degree of polynomial is 2, it is called quadratic polynomial. If degree of polynomial is equal to 2, then it is called quadratic polynomial. Now if you look at this example, then highest power of variable is equal to 2. That's why degree 2, and it is called quadratic polynomial. Similarly, if degree is 3, it is called cubic polynomial. If degree is 3, then it is called cubic polynomial. You can see here, highest power of variable is 3. That's why degree 3, and it is called cubic polynomial. Then for the next cases, means the degree 4, 5, 6, any means more than 3, it is simply called as polynomial of degree 4. There is no specific name for name for the next degrees. That means if degree is 4, it is called polynomial of degree 4. Degree 5, that means polynomial of degree 5. Simply we can read it. Then next topic, values of polynomial. These things we also learn in the standard 9. Values of polynomial. One polynomial is given, and then we can find the value whatever question is there. So simply, one example, p of x is equal to 3x plus 2. Then value of polynomial p1, means in place of x you need to put 1. So here a polynomial is 3x plus 2. So I am simply in place of x I am writing 1, and plus 2, this constant term as it is. So 3 ones are 3 plus 2 is equal to 5. Similarly, p2, that means in place of x put value 2. 3 2s are 6 plus 2 as it is. Answer is 8. Minus 1, polynomial p minus 1, p of minus 1, that means in place of x put value minus 1. So plus 3 multiply minus 1, I am writing in bracket. It means it is a multiplication process. So 3 ones are 3 plus minus minus 3, then plus 2 as it is. Now it is the addition subtraction process. So plus minus minus, 3 minus 2, 1, big number sign, it is negative. So answer is minus 1. So we can find value of polynomial for any value of x. For that polynomial is defined. Okay, this is the value of polynomial. It means that at zeros of polynomial. Now what is the meaning of zeros of polynomial? I already written here value of variable. For that value of polynomial becomes 0 is called zeros of polynomial. Value of variable, for that value of polynomial becomes 0 is called zeros of polynomial. I think it is difficult to understand. Then read second line. Value of x, for that p of x is equal to 0 is called zeros of polynomial. What is the meaning of zeros of polynomial? That means value of x, for that p of x is equal to 0. Let's understand by one example. P of x is equal to 3x minus 1. Now if we put x is equals to 1 by 3, okay, then p 1 by 3 is equals to, now 3x minus 1 is given, I am putting 1 by 3 in place of x and minus 1 as it is, then 3 cut, so finally 1 minus 1 is equals to 0, right? So that is written here. So for x is equals to 1 by 3, value of polynomial is equals to 0. This is the definition of zeros of polynomial. That's why we can say that x is equals to 1 by 3 is called zeros of polynomial, right? For x is equals to 1 by 3, value of polynomial 0. So x is equals to 1 by 3 is called zeros of polynomial. If we put x is equals to 0, then p of 0, 3 in place of x, I've written here 0 minus 1, 3 into 0 0 minus 1 is equals to minus 1. This is not the zeros of polynomial. Zeros of polynomial, it does not mean that we can put x is equals to 0. No, it's wrong. What is the meaning of this? That is, for x is equals to 0, value of polynomial minus 1. For x is equals to 0, value of polynomial minus 1. But in definition, what we've written, that is, for value of variable, it must be value of polynomial need to become 0. Here minus 1 is there. It is not equals to 0. That's why it is not called zeros of polynomial. So just understand the difference between zeros of polynomial and value of polynomial. It is called value of polynomial for x is equals to 0. It is not the zeros of polynomial. Okay. So what is the zeros of polynomial? Again I am saying that for value of x, for the value, that means for value of variable, for that polynomial becomes 0, is called zeros of polynomial. Next topic, degree of polynomial. Degree of polynomial we already learned. It is the highest power of variable, but it is also equals to maximum number of zeros of polynomial. Degree of polynomial is equals to maximum number of polynomial. Now let's take some example. If degree 0, then number of zeros is equals to 0. If degree 1, number of zeros 1, because what I written here, degree of polynomial is equals to maximum number of polynomial. One more thing, if degree is 1, then there is two possibility for the number of zeros, that is 0 and 1, right? Because what we write here, maximum number of zeros. So degree 1, that means maximum number of 0 1. So two possibility 0 and 1, but I already I write 1 only. I explain this reason later on when I will explain a graph of polynomial. Okay. If degree of polynomial is equals to 2, then how many possibilities for number of zeros? So number of zeros, it can be 0, 1 or 2. If degree 3, then there is a possibility for the number of zeros is 0, 1, 2 and 3. Okay. So if degree is 2, then it may happen that polynomial have one number of zeros is equals to 1, 2, otherwise 0. That we will learn in next part. Okay, how many number of zeros we can find, that I will explain later. before the explanation of graph, I want to explain you one more thing. Take one example. P of x, just a minute. P of x is equals to x square minus 1. Now take x is equals to 1. Then 1 square minus 1, that means 0. And take value minus 1. So minus 1 square minus 1, and minus 1 square, it's also give positive answer, that means plus 1, because even exponent is there. So 1 minus 1, 0. Now if you take x is equals to 1, then your answer p of x is equals to 0, and for minus 1 even your answer is 0. So by the definition you can say that x is equals to 1 and x is equals to minus 1 are the zeros of polynomial. That means 1 and minus 1 both are called zeros of polynomial. Okay, so 1 and minus 1 are your zeros of polynomial. But how many number of zeros you can find here? That is 2, because you find 2 values. For that your polynomial becomes 0. So how many total zeros are there? 2. One is 1 and second one is minus 1. So two things is there. One is zeros of polynomial and second thing is number of zeros of polynomial. Now zeros of polynomials means here 1 and minus 1. But if you say number of zeros, how many zeros you can find? That is 2. Okay, so number of zeros of polynomial is 2. It means that you can find 2 value. Okay, and 1 and minus 1 is called zeros of polynomial. So this is the difference between zeros of polynomial and number of zeros of polynomial. Okay, next, graph. I explained you earlier even that linear polynomial always gives graph as a straight line, right? Now how can we draw the graph? I'm taking one example here, that is px is equals to 2x minus 4. Now in the graph here two things is there. One is the value of x and second is the value of px. So value of x is represented on x-axis and value of p of x is represented on y-axis. Okay, p of x is represented on y-axis. So in place of p of x I am writing y. Simply I am writing y here. Okay, so y is equals to 2x minus 4. Now it becomes one linear equation that you already learn in standard 9 chapter number 4, linear equation. Now we need to draw the graph of y is equals to 2x minus 4. So what is the simple way? That is the intersection point with the x and y axis. So two values we can find. First of all, take for x is equals to 0, then find the value of y. So in place of p of x I am writing y here, 2 as it is. In place of x write 0 minus 4 again as it is. So y is equals to, now 0 into 2 0, so only minus 4. So y is equals to minus 4. In second thing, now take y is equals to 0 and find x. Okay, now take y is equals to 0 and find x. So y is equals to 2x minus 4. In place of y put here 0, 2x minus 4 and find x. So transfer 4 to the right hand side, that means 4 is equals to 2x. Then transfer this 2 to the left hand side, it goes in division. So finally 4 by 2 is equals to 2. So x is equals to 2. So if you take y is equals to 0, then your x is equals to 2. Okay, so we get 2 points from here. That is, first one, x is equals to 0, y is equals to minus 4, and second one, y is equals to 0, x is equals to 2. So x is equals to 2 and y is equals to 0. If we put x is equals to 0 and if we get y is equals to 0, then we need to take different value here. We cannot take again y is equals to 0 because it will show as x is equals to 0. So these 2 points are same, but we want two different point. Okay, so if you put x is equals to 0 and get y is equals to 0, then you need to put some different value other than 0. Okay, so you will get two values. Now give value to the x and y axis. Now first point is 0 and minus 4. So x coordinate 0, y coordinate minus 4. Okay, x coordinate 0 is here and y coordinate minus 4 is here. So this is the point 0 minus 4. Second point 2 0. So x on x axis value 2 and y 0. Okay, so this is your point 2 0. So join this 2 point and draw one straight line. Okay, if you draw the straight line, after that you can find the value of p of x for any value of x. That means if I want to find p1, right, p1, that means x is equals to 1, then join this 2 point. Okay, for 1 on y axis, what answer you get? Again, for 1 on y axis, what answer you get? That is minus 2. So you will directly find value of p of x. That means your p1 is equals to minus 2. Now again recall the definition of zeros of polynomial. Zeros of polynomials means value of x. For that your p of x is equals to 0. But in graph, where you can find p of x is equal to 0? P of x we will represent it on y axis. That means our y need to become a 0. If you remember, then on x axis your y is 0. Okay, 1 2 3 different values is there, but y is equal to 0 you can find on the whole x axis. Okay, again, what is the coordinate of this point? It is 2 0. First value represent x axis, that means x. Second value represent y axis, that means p of x. So your p of x is 0 for the value of 2. So you can say that x is equals to 2 is zeros of polynomial, right? Because whenever x is equals to 2, your p of x becomes 0. So x is equals to 2 is your zeros of polynomial. But for that, for finding out zeros of polynomial, you need to have a coordinate of this point. If coordinate is not given, then you cannot find the zeros of polynomial. But second thing, that is number of zeros of polynomial. Now how we can find number of zeros of polynomial? Again I'm drawing x and y axis. Okay, now in place of this straight line, I am using this graph. Again, this is your p of x, this is your x. So at which point your p of x is 0? P of x is 0 on the x axis and your graph touches the x axis at this point and this point. Okay, these 2 points your graph touches with the x axis, and on x axis your p of x is 0. That means at this point and at this point your p of x is equals to 0. Okay, so these 2 points becomes your zeros of polynomial. So how many values you can find here? It is 2. So your number of zeros is equals to 2. Okay, 2 values you can find. For that your p of x becomes 0. That's why your number of zeros is equals to 2. But in straight line, means in linear polynomial, always straight line touches with the x-axis at one time only. So for every linear polynomial, number of zeros is equals to 1. Okay, that means ultimately what we can say that number of zeros is equals to intersection point of your graph with the x-axis. I am writing this line but in the next page. Okay, so at that time we again recall it. Now at the time of explanation of degree, I explain one more thing to you, that for linear polynomial means degree 1, the number of zeros, I am saying that it is 1. It cannot be 0. Why? So when number of zeros is equals to 0, it means that your straight line do not touch with the x-axis. That then it needs to become a parallel line with the x-axis, because parallel line does not intersect to the x-axis. Okay, so for the parallel line, what is the equation of this line? Means y is equals to some constant value, suppose 2. So if you take this equation, that means y is equals to 2, then this becomes your zero polynomial. Now remember, zero polynomial and linear polynomial. Zero polynomial means constant value, so here is constant value we can find, so it is called zero polynomial. Okay, it is not called linear polynomial. So linear polynomial always intersect graph with one point. That's why number of zeros in linear polynomial always 1. Okay, next. So I've written here that one conclusion, that number of zeros of polynomial is equals to number of intersection point of graph with the x-axis. For example, consider this 2 example. Here intersection point with x-axis 1 and 2, so number of zeros 2. Again here 2 intersection point, number of zeros 2. This theory we will use in exercise number 2.1. Okay, at that time we again recall this theory. Now in quadratic polynomial, first of all, standard form of quadratic polynomial, it is ax square plus bx plus c, because for quadratic polynomial your degree is 2, that means maximum highest power of variable is equals to 2. Now if you increase the value of x, then x square is more increased than the x, and x square always gives positive answers 2. Okay, so quadratic polynomial is always depend on this term ax square, because it is joined with the x square and value of x square is more than x. So if your a is positive, then your values of polynomial becomes increased, so your graph shows upward direction. If a is negative, means less than 0, then your value of polynomial becomes negative and it shows downward direction. One more thing, a cannot be 0. A cannot be 0, because if a is equals to 0, then put this value in this equation. That means 0x square plus bx plus c. But 0x square, that means 0, so only bx plus c you get, and this is linear polynomial, not quadratic polynomial. So for quadratic polynomial a cannot be 0. Okay.